We are going to transfer textures from a few input images to a 3D shape. This lowers the barrier of 3D content creation for everyday users. We can easily transfer textures across arbitrary categories, making everyday objects a source of inspiration. For example, you can take a few photos of your plush toy and create new variants. Or take your favorite cup and design a series of furniture that matches your style. Or make everything a little bit more fluffy. Our generated textures are relightable and compatible with the standard graphics pipeline. Let's see how we can build this method. Given a target 2D mesh, our goal is to learn a BRDF field. We model this BRDF field with neural implicit representation that maps arbitrary points sampled on the surface of the mesh to 3 parameters: diffuse albedo, roughness, and metallic. These 3 parameters allow us to model a wide range of surface appearances. But then, how do we generate such texture? Let's start with text-to-3D generation using diffusion models. We first select a camera viewpoint and render an image using differentiable rendering. We sample a Gaussian noise and create a noisy image using forward diffusion. We can now learn the texture by leveraging 2D diffusion prior. Here we have a detailed description of the appearance we have in mind. We use the 2D diffusion model to estimate the noise and use the noise residual to update the parameter theta. This process is known as score distillation sampling, or SDS. This is cool, except it doesn't really work. It's difficult to convey the visual appearance with text precisely. Let's fine-tune the diffusion model to capture the specific appearance from the input images. Here, the fine-tuning also learns a unique identifier for the specific object. Plugging this back to the score distillation sampling method, we get something like this. That's great progress. But there are still lots of artifacts, such as unnatural colors. We can improve this by adding the pre-trained diffusion model back with camera encoding conditions, and using the noise residual from the 2 diffusion models for backpropagations. This is known as variational score distillation. Great, now the colors look a lot better. But whoa, where do those artifacts come from? This is because the diffusion models only see 2D images. To fix this, we need to make the model geometric aware. So, in addition to color images, we also render the surface normal from the 3D mesh. We use them as conditions for the diffusion models using ControlNet. Now we can transfer realistic, semantically meaningful textures to arbitrary objects. Once we optimize the BRDF field, we can easily extract the relightable texture maps and use them in the standard graphics pipeline. Let's see some comparisons. LittlePen used textual inversion to extract image information into text embedding, and then optimize the texture with SDS. Textures fine-tunes the diffusion model and synthesize the textures with an iterative mesh painting algorithm. Our results showcase better visual quality than the previous state-of-the-art. We are super excited to take a step toward democratizing 3D texture creation. Thanks for watching, and I will see you next time.